Now, let's look at how attention works within the encoder-decoder context. Attention helps the model determine which parts of the input are most relevant when generating each part of the output. When the input sentence is long, it's inefficient for the model to treat every word equally. Instead, attention allows it to focus on the most important words or phrases for the current prediction. For example, consider the sentence, "I love llama." When translating it into another language, the model learns to pay attention to different words at different times. When generating the translation for I, it focuses mostly on the word I. When processing love, it gives more weight to love. And when translating llama, it focuses on that specific word. This selective focus ensures that the model captures the correct meaning and context for each part of the sentence. Here's how it works internally. The sentence, "I love llama," is first converted into word embeddings, numerical representations. These embeddings are passed through the encoder RNN, which produces a context embedding, a summary of the input. The attention-based decoder then uses this information to decide which parts of the encoder's output are most relevant for generating each output word. In short, the attention mechanism helps the decoder look back at the encoder's outputs and assign different importance scores to each word, ensuring better understanding of meaning and relationships. That's the essence of attention in the encoder-decoder framework.